Okay, so we've looked at the great white shark length and the housing costs and the survey data and determined the measures of central tendency, when you might use those, what are the pros and cons of each. But let's talk about measures of dispersion. So the easiest of those is the range. It's just the lowest value to the highest value. I've already calculated it, but if you order these from lowest to highest, you just take the lowest number to the highest number and you just write that out, and that's your range for each of these measures. But that is problematic because you could just have a very low number or a very, very high number, and it doesn't really tell you the average spread outedness, as we say, about the data, and that's where standard deviation comes into play. It's a better measure of the average variation among the mean or around the mean. And so we've used this formula before. Here it is again. You can see it, and it's quite interesting to look at the level of variation, especially the level of variation relative to the mean. So we're going to talk about that in a second. But another term you see is standard error. Standard error is calculated from the standard deviation, and it simply is the standard deviation divided by the square root of the sample size. So we can actually build a formula in here because there's no existing one in Google Sheets to do this. So we'll just do equals, and we collect the click on the standard deviation, and then we're going to do divided by, put in parentheses, and we're going to type in square root. So I started to write SQ, there it is, square root of the sample size. Now the sample size is this entire value, the number of measurements that we had. So what we can do to get that is type in count, and count is a function that will look at the number of values in a data set. So there we sum it up, and we close out the parentheses, hit enter, and here is the standard error. It is 0.59 for the shark data set. You can drag it across and it will accurately calculate for each of these other areas. And we can turn this to number. And so the first thing you notice is that standard error is always lower than standard deviation. And that's because it is dividing by the square root of the sample size. And the larger your sample size, the smaller your standard error is generally going to get. But other than that, it's proportional. So it's kind of up to you which you use. I generally recommend standard deviation, but just note it when you see it in a paper, which measure you're looking at, and understand that standard error is going to be smaller than standard deviation. So the final measure I want to show you is coefficient of variation. Like I started to say, the ratio between the standard deviation and the mean is interesting to consider, and that's really all the coefficient of variation is. You just divide the standard deviation by the mean. And in this case, it's 0.13. So let's drag it across and just see how these compare and what this means. So this is usually, coefficient of variation is usually presented as a percentage. So let me just drop that in there. So what this is saying is that the standard deviation is 13% of the mean in the shark length data set. But in the housing data set, the standard deviation is 77% of the mean. And you can look at that, 500,000 is about, or is 77% of this number, 654,000, right? So, and then finally, even though this data set only ranges from 1 to 5, the coefficient of variation is quite high, 64%. That's because the standard deviation is 1.4 and the mean is 2.2. So 1.4 is 64% of 2.2. What this tells us is that this is the most variable, the housing data set is the most variable data set, right? And the survey data is the next most variable, followed by the shark length data. So it's important to keep the coefficient of variation in mind, and it can be quite useful in summarizing things and seeing things that you might not otherwise notice. Final thing I want to mention is when you go into scientific papers, such as this one, it's called The Benefits of Protected Areas for Non-Breeding Water Birds Adjusting Their Distributions Under Climate Warming. When you scroll down and you look at different figures and tables and such, you are going to see representations of measures of central tendency, like an estimate number, and then in parentheses, they might say something like SE. Well, that stands in this case for standard error. So they're giving you a measure of the variation around this average or this estimate. You might also see SD, and that would be standard deviation. So keep an eye out for this. You'll see figures that have whisker lines or lines above and below, which generally indicate some measure of variation. It might be standard error. It might be standard deviation. It might be something else like a confidence interval that we haven't covered yet. But the general idea is that it's showing you variation around the data point.